Following Hurricane Katrina in 2005, the U.S. Army Corps of Engineers and the Federal Emergency Management Agency, along with their partners, have deployed innovative simulations and analysis to better measure hurricane storm surge flooding. This effort culminated in the development of the Coastal Hazards System, a national-scale, multi-agency initiative that provides accurate, robust, and consistent quantification of coastal storm hazards along all U.S. coastlines and other locations of interest to national security. Its data can be used for various applications, including coastal engineering, risk assessment, and inundation mapping.
One of the most important goals that we're trying to achieve is estimating risk for our coastlines because there are millions of people who live along the coastlines. It's really a unique data set that allows people to assess their hazards for their given location and then apply this as they need. CHS provides the capability to evaluate impacts from millions of potential hurricanes and other coastal storm scenarios, all while accounting for sea level rise and future climate change scenarios.
Hurricane Katrina was in 2005, and that provided the impetus for the agencies to come together, bring academia in, and bring the private sector in, and all the experts together at one time to develop a technological revolution in the area of coastal storm hazards that feed flood risk. There's nothing like it that I'm aware of in the world where you have very high fidelity modeling that spans probability space.
USACE coastal projects, federal research and development initiatives, flood risk mapping, and emergency management activities all use CHS storm data to plan, design, and ascertain risk. These activities are supported through its extensive high-resolution numerical modeling and machine learning-based analysis. Additionally, CHS has led to improved understanding of complex coastal storm processes by federal, state, and local governments and the public at large.
As engineering with nature pushes the envelope and continues to create the state-of-the-art in the EWN practice, it's really important going into all of these different research projects that we have the best statistically significant data. And we also now have the best data thanks to the Coastal Hazards System. What's going to happen with climate change, what's going to happen with sea level rise, so that our engineering with nature projects can be efficient and include the maximum resilience that we want these projects to include.
Among the Engineering with Nature projects that have used the Coastal Hazards System is an effort to make Tyndall Air Force Base more resilient as it's rebuilt after suffering heavy damage from Hurricane Michael in 2018.
And we took a look at the map and we said, here's the areas we're worried about. And the CHS gave us the opportunity to communicate where EWN was needed, what the scale of EWN was needed, and how we could help create a more resilient coastline for that installation.
The CHS, of course, being a coastal storm database, provides the backbone for our coastal studies. And so the CHS is beneficial because it has a full range of possible storms for your given location. It's not limited to only those that have occurred. And some of the most relevant storms are ones that may not have yet occurred in your study area. The Coastal Hazard System is now out there, but it's state-of-the-art, and it includes everything that we need, and it's actually geared precisely for the work that we do.
We use it to help us, one, understand, how we design the project, so we're using it for water level and wave loads on the project, but also to understand the frequency of flooding in the area that we're protecting. We're also using it to reassess the project. So as the CHS is being updated, the water level statistics are changing, we're looking back at the system on a recurring basis to say, hey, this part of the system is no longer sufficient, or it now provides this amount of protection, and then we're able to give that to our partners who communicate it back out to the public. This is the only source of data for coastal water level statistics that we have, and it's super important that we keep it updated and it's available for us when we're doing these projects, or it'll add a really big cost and time burden to the projects.
It's a very comprehensive system that encompassing high fidelity, high resolution numerical model simulations, very sophisticated multivariate statistics. That's part of the statistical framework that we're expanding now to account for compound flooding. We have elements of machine learning and meta modeling that we can efficiently simulate and estimate the hazards for up to millions of storms. ERDC is uniquely capable of conducting research that leads to the development of technologies like the coastal hazard system. We have the technologies that we need, like the supercomputers, and the expertise of our teams includes researchers, engineers, meteorologists, statisticians, information technology support, and many others. As part of the CHS, we are constantly conducting R&D so we can push the state of the practice and the science forward.